Hi, I'm back with my third day of learning. This is the third video of the playlist. You can see overview here. I watched the whole video and made some notes. I will tell you what I learned today. You can click on their GitHub link for the summary of the video. Read or translate the summary in your own language using AI. Okay, so you can see here is my note of lesson 3. First of all, we can see the components of a programming language. A programming language fundamentally consists of three core components: input, processing, and output. Here you can see a diagram in which you can see input, processing, and output step. Okay, for input, how the program receives data is input, like keyboard input, files, etc. Processing step, the logic and calculations performed on that data. For output, how the program returns result, for example, printing to a screen or writing to a database. Okay, so here you can see two types in processing. One is foundational and other is structural. For foundational processing, here you can see 6 steps: variable, statement or expression, operator, logic, function, and array, key value pair, etc. Okay, so foundational concepts. What is a variable? In simple programming terms, a variable is like a container or a box where we store information or data. For example, when a computer performs a task, it needs to remember certain information. This data is stored in memory. However, memory addresses are very complex. When we use a simple name to store data at that location, instead of using a difficult address, it is called a variable. There are 3 elements of a variable: name, value, and data type. Why are variables needed? To remember information, to make code easier to understand. History of variables. Where did they come from? Okay, here I have written a brief history of variables. I used Gemini. You can use any ChatGPT and learn anything. Okay, moving on to next. Why were variables created? Before variables, people had to write code at the hardware level. Their evolution occurred for 3 main reasons. For human readability, 2 for reusability, and third reason is abstraction. So the programmers can focus on logic without worrying about the underlying hardware. Okay. Now move on to next. What is a statement and what is an expression? In programming, understanding the difference between a statement and an expression is like understanding the difference between a word and a sentence in grammar. Expression is a piece of code that provides a specific value after being processed. Simply put, anything that calculates a result is an expression. For a statement is a complete instruction or action. It tells the computer what to do. A statement can contain one or more expressions, but the statement itself it does not return a value. It completes a task. Okay, move on to next. What is an operator? In programming, an operator is a special symbol used to perform mathematical or logical tasks on variables and values. There are four types of main operators. They are arithmetic, assignment, comparison, and logical. What is a logic? Simply put, logic is the ability to make decisions. For a computer, logic is a set of rules or conditions that determine what the computer should do in a specific situation. History of logic. How did it start? Here is a short story of logic. How logic works. In hardware, these logics exist as logic gates. The three main logics are AND, OR, and NOT. Now, what is a function? A function is a block or packet of code created for a specific task. It is like a machine. You give it an input, it processes it internally and gives you an output. Think of it as a recipe. You don't rewrite the rules every time you cook. You just follow the recipe. How functions work? Okay. Here are three in part in the function. First is input or parameter. Second is logic or process. And third is output or the return value. History of function. Here is a brief history of functions, why it is created, and here you can see key array and key value pair. For array, a list of row or similar data where each item has a specific position called an index, derived from mathematical metrics and vectors. For key value pair, a system where every piece of data has a specific name, often called a dictionary or object, derived from real-life dictionaries or index cards. Why do they exist? Arrays allow us to process large amounts of data quickly. For example, averaging the ages of 1,000 people. For key-value pairs, allow us to find specific information instantly without searching through everything. For example, finding the name of roll 520. Okay, move on to the second part of processing, which is structural paradigms. First part is object-oriented programming or OOP. Object-oriented programming is a paradigm where code is organized based on real-world objects. There are four pillars of object-oriented programming. They are encapsulation, inheritance, polymorphism, and abstraction. Encapsulation, hiding the data inside a capsule to prevent external corruption. Inheritance is passing features from a parent class to a child class to avoid repeating code. Polymorphism, performing the same action differently in different situations. Abstraction, hiding complexity and showing only the necessary parts to the user. Okay, now move on to functional programming. Functional programming emphasizes the mathematical solutions over direct instruction. For pure functions, no side effects, same input always gives the same output. Immutability, data cannot be changed once created. For first class functions, functions are treated like variables. Okay, move on to design patterns and principles. Design pattern is a blueprint or standard solution for recurring problems in a software design. Design principles are fundamental rules that help create clean, maintainable code. Okay, you can learn more about design pattern and design principles. You can ask Google or any AI. I'm using Gemini. Okay, so what is a design pattern? Okay, you can read broadly about design pattern here. And for design principles, I will again copy and paste on Gemini and we'll study from here. Okay, I started a brief for the basic idea. I will learn more about these patterns and principles later. Move on to next. What is DSA? DSA is equal to data structures and algorithms. Data structure is how the data is organized in a computer for efficiency, and step-by-step instruction to complete a task is called algorithm. You can learn more about DSA in Gemini. I am going to copy and paste it to Gemini. Okay, so you can see it gives a description about DHA. Okay, move on to JavaScript. Move on to why JavaScript is called a wired. Okay, move on to next. Why JavaScript is called a weird language. The reason JavaScript is labeled this way is that it blends object-oriented and functional programming in a manner that often confuses beginners. Below are the primary reasons explained. Okay, I learned this from AI and put it my note. You can learn from there. The first reason is strange mathematical results. JavaScript sometimes changes data type automatically on its own. For example, here are the examples. Second reason is the mystery of NaN, not a number. In JavaScript, NaN stands for not a number, but interestingly, if you ask type of nan, JavaScript says it is a number. Furthermore, nan is equal to nan, results is false. This means NaN is not even equal to itself. Then type checking, double equal or triple equal. Using double equal in JavaScript leads to very strange results. This is why I always recommended to use triple equal in JavaScript. Okay, the story of JavaScript created in 10 days. Why is JavaScript so weird? The answer lies in its history. In 1995, Brendan Eich created the first version of JavaScript in just 10 days. Because it was built in such a short time, many minor flaws or inconsistencies became deeply embedded in the language. This couldn't be changed later in order to maintain backward compatibility. Okay, the fifth reason is global variable and this keyword. In other languages, this keyword works very clearly. In JavaScript, however, the value of this changes depending on where and how the code is called. This often becomes a major headache for new programmers. Sixth reason is prototypal inheritance. Unlike other object-oriented languages, JavaScript is not natively class-based. Although we can use class keyword now under the hood, JavaScript still functions using prototypes, which can feel strange. A perfect example is this. Okay, JavaScript is called weird precisely because it keeps the program running by shifting data types in such peculiar ways. Okay, conclusion. JavaScript is indeed a weird language, but it is currently the most popular and powerful language in the world. Okay, so this is it for today. Thanks for watching my video. Please subscribe to watch my progress journey.